Let me probably welcome everybody who joined this session. I hope you enjoy the conference so far, and I really hope it will be interesting for you to discuss. Just a quick disclaimer. So whatever we will be discussing, just don't hesitate. Drop your questions into the chat, or if you really have to add something, just raise a hand by message in the chat or somehow else, and we'll be glad to discuss it together with you, or at least answer the questions that you post into the chat. Right? Just general statement from me of why we were actually interested in discussing this, and why we conducted some local discussions earlier this year. It's because it's a really interesting state when there are plenty of different JVM languages with their niches, and also pretending to be successors of Java, or they have pretended so for some time to be successors of Java, right? But at least what I can see is that Java is not surrendering. It is in some sense cannibalizing on the achievements of those JVM languages and filling the gaps, and like also keeping up to date and keeping the development speed. That's why we just decided to bring this topic up and discuss what is the actual state of major JVM languages, right? Of course, we won't be able to discuss all of them, but at least the major ones. So probably, again, let's probably start from the, I don't know, the one of the oldest of the famous JVM languages is Groovy, right? And because we have limited time, probably it will be easiest for us to discuss this one, right? Just a couple of words from myself regarding Groovy. So if we ask ourselves a question, will it be a successor of Java? Then probably everybody is clear that no, it will not be a successor of Java. It will only probably be able to play well in some niches. So at least niches I see is Jenkins pipelines, because in Jenkins pipelines it is de facto the only native language. And from the discussions that I was able to read on the internet, creators of Jenkins and supporters of Jenkins really don't want to onboard anything else besides just Groovy. So it will be Groovy and period. And also another big thing is Gradle build scripts. Also, that has become kind of controversial, right? We'll discuss why. But guys, what do you see as a niches or possibilities for Groovy to grow in them?
So, can I start?
Yeah, sure.
Basically one of the key ones I've touched Groovy in is tests, and reason for that, Groovy introduced when it appeared kind of whole different level of flexibility in the syntax, and it's allowed writing tests in the manner that no one could even imagine them before, having tables of data or having different constructions to test collections. This was amazing. Specifically, I'm talking about Spock Framework. And the reason for this flexibility is obviously because Groovy doesn't have static typing. And that's the same reason why it can't really be a contender for production code, because you can't really guarantee that it works until you run it. Well, at least still it's not JavaScript, but it kind of makes it weaker compared to Java or Kotlin.
Yeah, actually about the Spock. To be honest, I've never, despite it is extremely popular. I've never actually used Spock, probably because I was mostly used on pure Java development tests. I don't know. Do you have any samples under your belt? Just for audience to give sense
I
of what it looks
sort
like.
of do, but I haven't found good ones because the last project with Spock I had was quite a long time ago. So I have something. It doesn't compile. Sorry, I mean, ID doesn't recognize the classes and whatsoever. Let me try and share my screen because let me know if you can see my screen. Okay, so basically the cool thing about Spock is you can do constructions like given when then. This is not a nice test, honestly. I found this. So you can annotate things with words rather than like methods. You can call them with words, and then you see what actually fails in natural language. Then another thing is you can do things like that. This is an assert, and it's kind of nicer than calling a method. It's more readable. And another one is that you can do things like this. This is a data table where it would unroll it into separate test cases and call this same code with different sets of data, and then give you an exact failure if something fails. So this is kind of cool. But then the downside of it is if you're using Groovy in the tests, it's not perfect with the IDE. So if you're refactoring things, especially if you run it, so I've been in several projects with Groovy tests and Kotlin, and then if you refactor things in
Sergey, I'm sorry, we can't.
It for some reason it got muted. Can you please? Yeah.
I didn't do it.
I don't.
So let me know when.
Yeah, I can hear now. That's fine now. So please proceed. We probably lost just a couple of %.
About refactoring.
Yeah, I say it just doesn't work. When you run refactoring with Kotlin, you rename fields and they get renamed incorrectly because probably IntelliJ didn't invest enough in Groovy support. So basically, it kind of causes pain, but the beautiful syntax was always winning for me until Kotlin native frameworks emerged, and I don't want Spock anymore. Well, that's probably it, but it's still cool.
Yeah, just a sense from my side is like, for some reason, the thing that was supposed to give Groovy immense popularity made it probably the most hateable of JVM languages. Like, it is dynamic nature of it, right? Because it was advertised as a dynamic language. Now it's one of the dynamic languages, right? Because there is closure and so on. So it was advertised as a dynamic language with which you can be really productive and expressive. But in fact, yes, that lack of refactoring support that you mentioned is caused exactly by its dynamic nature. And so basically, having spent weeks or maybe months debugging Gradle plugins in a build tool, right? And when being a part of infrastructure team and writing Gradle plugins and having need to debug them and to troubleshoot them, I really hated Groovy. That's why, so like Victor from the chat says that whoever works with Groovy hates it. Yes, I hated it as well. I don't know why the maintainers of Jenkins prefer Groovy on the first place, and maybe I'm wrong. That was just a discussion I saw that like core maintainers of Jenkins just said that will be Groovy and no other language will be onboarded as a native or a substitution to Groovy. And I won't really think that I wouldn't for Groovy to exist, but basically, again, its dynamic nature gives it really low entry threshold, right? But actually, whenever it becomes more or less sophisticated, right, you get into trouble. But again, like if so, one thing that I was surprised to see, I have. So let me probably try to share my screen. So despite like this is a famous TOB index, right? And despite so can you see now? Yeah, and basically despite being like the most hated language in the JVM ecosystem, it is the highest one in ratings, right? After the Java, right? Most likely it's because of again Jenkins pipelines and Groovy build scripts, which for build scripts I actually think there is alternative, that is Kotlin DSL. We can probably talk in more detail about that when we get to Kotlin, but still actually. So I've did a bit of research, and for now, Gradle not only has a full-fledged Kotlin DSL support, it actually promotes Kotlin as a better alternative to Groovy, and there are also some inherent benefits because Kotlin is a static language, and your build scripts instantaneously get a lot of IntelliJ IDEA, for example, support in terms of refactoring, code navigation, and so on. And again, when you have really rich plugin system or build scripts systems, that's probably invaluable. One thing that you do not have better scripting style JVM based language, unfortunately. Probably not. There was like at the time I was working with WebLogic, there was JRuby, Jython, and so on. So like quite decent alternatives, but for some reason they didn't get as much adoption as Groovy did. But I didn't. At least I remember I didn't hate them that much as I hated Groovy. Probably because I didn't had to use them so extensively. So that's probably the reason.
Likely to be the
Again,
reason. Yeah, you just haven't done any bumped into any big problems with them. Well, you have with Groovy.
yeah. Maria, do you have any opinion of Groovy? Do you hate it, or you
Okay.
just try to admit it?
Actually, maybe I'll say some terrible thing, but I don't have Groovy. Actually, I don't have a big experience with it. I faced with it, I believe, some time ago, only in Jenkins pipelines. It was good enough for my purposes. That's all that I can say. It worked in scripts, but as for me, the word dynamic is enough to see some potential problems in language.
Yeah, that's true. Because to be honest, that's my personal opinion as well. At least probably it's because I'm coming from a static Java world, and I really value such property of a language as unambiguity. Right? It's when you can reason about the application or a specific like building block behavior just by tracing source code. You can just read and like navigate through your IDE and get a sense of what it does without any tricks and surprises in runtime. Because for Groovy, it was impossible to know how it will behave until you actually run it several times, debug it with print statements just trying to debug it with debugger with no success sometimes and so on. So yeah, I would second your opinion here that probably we're not dynamic enough guys coming from Java world. Okay, does anybody have anything to say about Groovy before we move to our second candidate, probably Scala? If not, okay, let's switch to Scala. And Maria, you're probably the best expert here to talk about what is the actual state of Scala. Why should we still care about it, or probably should we at all? Just
Okay.
That was mean.
I'm provoking, yeah.
Yeah. At the beginning, a few just very common words. Maybe all of listeners already know it, but let's try. Scala is JVM language that isn't really unexpected, I think, according to our topic. It supports different programming paradigms. It's object-oriented programming and functional programming. And I'd say that Scala really enforcing approaches of functional programming in just daily, to use them in daily basics, like immutability, like pure functions and higher order functions, etc. What about current state? Currently, we have latest version 2.13, and also we have widely used 2.12 and 2.11 versions. And I have to say about it because unlike Java, Scala unfortunately doesn't have full backward compatibility. Yes, we can say that this decision has some pros and cons, that it helps us to avoid a huge amount of legacy, but being honest, in terms of business value, it's not the best decision, and it was done. Now we just understanding how to live with this decision. So currently there are a few versions of Scala that currently widely used. Scala 2.11 is, I'd say, still alive because of Spark. Second version of Spark works with Java 2.11. Third version was moved to
Scala
2.11. Yes, sorry, Scala 2.11, thank you. Third version of Spark works with Scala 2.12, and at least on docs, they plan to support 2.13. But currently, there are a lot of projects working with second Spark and 2.11 version of Scala. And also, third version of Scala, third minor version, 3.0 or Dottie, is almost here. At the beginning of November was released 3.0.0 milestone 1, and we are expecting version 3 at the end of this year, what is quite close for now.
Curiosity, what's the main evolution between those?
Version 2.12 were released for JVM version 8. So there were a lot of significant changes introduced in 8 Java, and a lot of these features were close to some Scala features. For example, interfaces with default methods are really close to Scala traits, etc. So Scala traits were introduced in just since the first version of Scala, and in version 2.12, they were changed the way how these features compiled. Java 8 introduced some features that are closer to things that already existed in Scala, and Scala changed the way of compilation. So that's the main change for Scala 2.12. And what about 2.13? 13, yes. It's just kind of version between 2.12 and 3. This version should help us to move from second versions to third. So less painfully.
Yeah, but actually, so as I can see from what is written about Scala 3, the biggest thing is Dota, right? But is it really a big thing in like besides just probably putting some consistency in Scala's backbone, right? Because as far as I could understand, because I'm nowhere an expert in Scala, but as far as I could understand, Scala 2 point star versions were written with a lot of dirty hacks, right? That would allow all that magic in the first place. And actually, I even listened to one of the podcasts about Scala, and one of the maintainers, not Dersky, but some of the main maintainers of Scala compiler was asked if it is realistic for somebody's PR into Scala core to be accepted from somebody from outside, right? And he said, really, I don't think so, because there are just like 2 or 3 people who could fully reason about all the consequences of certain changes and understand all the details of certain change and certain functionality and how they interact with each other. So when a couple of years ago I first heard about Doti, right, that it is going to be next big thing in a Scala world. So the main argument in favor of it was that it will put some consistency and mathematically proved correctness inside Scala compiler, right? But like what I don't understand is will it give some visible benefits to Scala developers?
Okay, I see. That's true that Scala compiler, third version of Scala compiler will provide us with more strict mathematical base for our type system. And what does it mean for us? In terms of practical usage, we will have guarantees that if our code was compiled successfully, we won't have any issues with type system on runtime. So we just have a guarantee that we will don't face the situation when some type system error code came from our code to our runtime. If it was compiled, type system works okay. So that's what it means in terms of practical usage. But yes, actually, I'd say it's the main feature. It's a very important thing, and I think it's quite important for all developers who work with strong type systems, with static type systems. Also, Dota introduces some other changes, some new types like intersection types or sum types, some changes in features that existed in second versions of Scala. For example, it brings significant changes in work with implicits. Introduces some new features like null safety, which is not really important when we are working with just native Scala libraries, but it could be very useful when we are working with Java libraries. In Scala, we can just add to our project any Java library and use it. And we can't expect from Java libraries some style that we are expecting from Scala libraries. And one of this moment is work with possible nulls, for example. In Scala, it's good style to use options when we can get a null. In Java, sometimes we just getting a null. And I'd say that opportunity to work with these situations just explicitly, it could be very useful, could really help to write better code, to get less errors.
Okay, yeah, sorry to interrupt you, Maria. Let me probably just, one thing that we really forgot is to introduce ourselves, right? And let me probably just fill that gap a bit right now. So actually, as you probably understood, Maria is our expert from a Scala world and a member of Scala Competency Center. And we also have Farhan just joined, who is lead software engineer and also having experience in Scala. Farhan. And myself, I'm probably just a Java developer trying to ask all sorts of nasty questions about all the JVM languages, just blame them without without reason. And we also have Sergey, who is probably our local ambassador of Kotlin, at least in our location in Kharkiv. We're from same location, and also has quite significant experience in writing in Kotlin and also in Java and other JVM languages. So having said that, sorry, Maria, please proceed, and I will leave you for a couple of minutes, and we'll be just right back.
Okay, I'd say that I've talked enough about main features of Dotty. So as for me, it's main point. It's improvement of type system. It's useful changes in implicit, in traits, etc. And it's as a new feature, I'd say that null safety is one of the most important features. Maybe it's for me because sometimes I have to work with Java libraries and in my projects. So something like this.
Shall we kind of touch where in today's world Scala lives? Like where would you usually choose Scala above everything else? I would assume it's big data, right?
Yeah, actually, let me speak from the big data point of view. So actually, first I want to start with the popularity of Scala in big data. I guess it would be fair compare Scala with the other languages, not just the JVM languages. So besides Python, R, and Java, it's one of the most widely used languages in big data. So regarding the useful features, why, for example, Scala is used by the data engineers, so it's type safety, higher order functions, partial functions, and pattern matching, things like that. So yeah, this is one of the main features one of the main features of language, why it's preferred by the data engineers. So there are actually two main tools and frameworks in big data that are written in Scala. One is the Kafka. Basically, it's the advanced message broker, and the other one is the Apache Spark. So it's a cluster computing framework. And for Kafka, I mean that for development, basically putting the subscribers, publishers, and all the other things around it. We are using the main language that is used is Java. For Apache Spark, the Scala is basically the industry standard. So if for the batch operations for previously, Hadoop was used, and for the real-time Apache Storm, basically Spark is combining the batch processing and real-time processing, and So, and the main language is industry standard for it is Scala. So Spark in itself, it says high-level libraries for Java, Python, and R, but the Scala, as I said, it's an industry standard. Yeah, that's pretty much regarding to the from the big data perspective why the Scala is popular. Besides that, yeah, I mean Scala can be used also for machine learning. It's but mostly widely used in big data by the data engineers, like the taking data from some place, transforming that data either then in real time or batch, and storing that data, transforming that data and storing to the to let's say to some other place for further processing. Okay, this is the perspective from the big data side.
Okay, and I'd like to add that Scala is useful not only in big data stack, but it's also used in backend development. So we have an ecosystem ecosystem that's enough to write code on Scala using only Scala libraries for backend development. Of course, not as popular as Java in backend, but honestly, I don't think that any JVM language will ever as popular as Java on its niche. Okay. And also, Scala works quite good with reactive systems. Maybe you know a company Lightband. It develops an Akka framework, Play framework. Actually, Akka, it's not really a framework. It's quite big ecosystem. Consists of different segments like Akka actors, Akka streams, Akka HTTP, etc. And also, this company, for example, participated in development of Reactive Manifesto. That's quite that's used as base for some standards in reactive systems. So the products of this company support these principles, and Scala is just native language for these products and works with them really good.
So is it, yeah, Akka is quite popular, so probably it's a big niche for them. Any other things that people do with Scala?
Okay, I'd say that Scala is really good for development some custom DSLs. We have strict data types. We have, which I can say some terrible words, some functional programming approaches. I even can mention some libraries used for implementation of these functional approaches. And based on these DSLs, we can develop really flexible DSLs for client business logic. For example, I have an experience of work with project where we processed some medical information. So it was files with some structure. Maybe some of you heard something about FAIR format, just format for medical data. We needed to extract data from these records to process this, and actually we had pretty complex logic of processing. And I'd say that functional approaches matched really good for these cases.
Is there a kind of how good is the native development stack? How many native libraries are there available for Scala?
You mean libraries for functional programming?
Yeah, for example.
Honestly, I can say that now it's CATS library. And actually, we have Scala Z too, but honestly, I'd say it's dying. So CATS library is actively developed. It has good support, good documentation, and it grows continuously. And in Scala Z, situation is less optimistic. It's used not as frequently, and it's almost stopped in development. So for now, I'd say that for functional programming, the standard would be CATS.
Hans, do you have any thoughts?
Actually, no, I completely agree with Maria. So, I mean, that the CATS is basically the leading library for if you are like into the functional style of programming. So that's the main library that's out there right now. So depending, I mean, that if you are if you really want to write in the let's say that if you want to use the features of the functional programming, that's the main library that you can use.
Maybe you have any examples, guys? Just curious, because I'm a Kotlin guy. I'm just curious how can it be better, or maybe much better than what Kotlin provides.
Okay, I have small example. I hope small example with implementation of monad. Maybe some of you heard this terrible word, and I just want to share that it's not a magic, it's just pattern, and this pattern could be really useful in some cases. In some other cases, it could be not as well, and just not use it in situation when it doesn't suit our purposes. But just one moment, I'll share my screen. I'll try to share. Can you see it?
Not yet, honestly.
Sorry, just. And now?
I cannot see.
Oh, that's strange, because I don't have any error messages.
Well, let's skip the examples. Let's discuss something else, maybe.
Just one more try, and now. Still can't see, yes? Okay, I'm sorry, I have no idea what's happening because I don't getting any error messages. I just trying to share it, and that's all.
That's weird.
Another thing that would be maybe like the main advantage of Scala. Why basically you would prefer to? Let's say that why would you prefer to use Scala instead of Java in the first place? Basically the way that I see it, the main advantage is that that is perfect for writing asynchronous, non-blocking applications, non-blocking backend. That's one of the main advantage that I see. So basically, if you are using, let's say that the Java, you have also always that thread, that the blocking thread, and that kind of things. But in Scala, of course, we can use the. Still, there is we can use Eric's Java, and we can use we can use the future and all other things in order to make the synchronous, in order to write the synchronous applications, non-blocking applications. But the Scala, it is just another level. It's completely different completely different way of thinking even than I mean in usual way that we are used to write in non-blocking applications in Java. Yeah, that's that would be one main like the main advantage of why someone would prefer to use Scala in I mean as a language for their particular case.
Actually, that's a great point. Honestly, I'm working with Scala mainly for 3.5 years, and it became so common that I even didn't think of it, that sometimes we have some other way.
Yeah. Yeah, but that's actually the way I see it. I mean, the main advantage of, and that's why it's used for things like Apache Spark, Apache Kafka, and so on, because it's perfect for writing a non-blocking distributed, for writing a non-blocking code, and for writing as an asynchronous code. Yeah.
Makes sense.
All right. Another thing that we wanted to discuss is
ecosystem, maybe the whole development stack and what's all around there.
Okay, from the point of view of backend developer, I can say that in Scala we have actually, I'd say, full enough stack to work only with Scala libraries in most part of cases. And I'd say it's quite important because, for example, in situation when we have a lot of cool language features, but we always need to work with libraries from some other language that definitely doesn't support these features, we really can use this feature just on daily basics, or we just happy that we have them, but we can't work with them. So I'd say that that's really great that we have, I'd say, full stack to require for backend development. We have libraries for work on HTTP. It's definitely like HTTP. It's Play. It's HTTP4S, and some other options, but these three are mainly used nowadays. We have libraries for work with databases. Now it's mainly Slick and Ruby, but we have some other options. We have Quill, Scala JDBC. Have libraries for work with files, for work with serialization and deserialization of our data in JSONs. And that's the main points of development application that works with HTTP on REST. But also, yes, in Akka we have options for streaming data processing, for cluster management. So I'd say in a lot of cases we have enough libraries, just Scala libraries, to write backend.
Even if we don't, we can always pick from. Even if we don't, we can always pick from Java. Okay.
Are there any problems with taking from Java?
Actually, the only problem is in Java we have some other way to work with errors, to work with possible nulls. And when we are taking some Java library to our Scala project, we need to be ready to process these situations. And I'd say that solve problems. For example, if we are going to use some Java library everywhere in our project, maybe it could be useful to create some wrapper. Maybe it's not necessary, maybe we can just work with library as is, but it's just necessary to remember that in Java we have different approaches in some cases, but I'd say no real problems in usage.
Okay, I think that we have only 10 minutes left. Is there any question from the audience that regarding to Scala, Kotlin, or maybe Groovy?
Not Kotlin yet. Kotlin is tomorrow.
Kotlin is tomorrow, okay. I thought, okay, all right. All right, then regarding to Scala, any questions? Okay, I see that there is no other questions. So
tomorrow we'll do a probably deep dive on Kotlin. I'll try to give an overview of what's there, why one would like to try Kotlin at least. I might say a couple of words about Kotlin for Android, but every Android developer knows it's just better. But server-side Java developers would usually say most of them just don't know how cool can it be. So we'll try to talk about it, and then we'll have Max who will and Maria and Orhan who will be trying to tell me why it's not as good as I think. So
all right.
Thanks everyone, and let's probably wrap up the session.
Yeah, there is no questions then. We actually presented all I believe that we had in our agenda regarding to Scala. Yeah, if there is no questions to discuss, Maria, maybe you have something to add from your side.
Okay, we just touched some functional approaches, and then there was some fail with sharing of my screen. But what I'd like to add about these functional approaches, there are some things that sometimes could be a bit scaring for newcomers, that some functional programming, monoids, it's too complicated, it could scare someone. And what I'd like to say is that it's a set of patterns. It works really good in some situations, for some data transformations, for some combination of data, and just not try to think of it like I will learn some magic. Try to think of it like I will learn some new patterns that could be useful for me in future development if you want to stay with Scala for a long time. So that's what I like to add about this.
Yeah,
Thanks.
Actually, from my perspective, I can also say that sometimes it's over exaggerated. This is completely new thing. Even if you are in Java, right, starting from the Java 8, you can use the map functional approaches, and that's if you are interested, you can even try that to write in the functional style even in Java. But the Scala, it takes it to the different level. And when you just start to work with it, it's a bit not scary, but it's a bit unusual. You just try to because you have been all your life you have been using the same approach for writing the code. It's just a bit different, but it takes in my experience about 2 to 3 months to just get used to it and to start. Just in my understanding, you're just switching. Let's say that if you're writing in some style, for the other style, you're just like the switching your brain, let's say, right? So you just switching to other paradigm, and it happens very quickly if you are used to it.
Yes, and Scala supports not only functional paradigm. If for some tasks it's better to use object-oriented programming, Scala provides you an opportunity to work with object-oriented world really great. And just choose an approach that's better for your current tasks.
Actually, sir, just wanted to ask a question. Have you ever seen a person promoting object-oriented style in Scala, right? Because I've only seen people just going on war with either functional or die. That's what I've seen.
Yeah, usually it's newcomers.
Yes, I totally agree that it's more newcomers position, honestly. So with experience, it comes understanding that all tasks are different, and it's better to choose approach that works really good in this case than choose to approach just right because you read that it's on the right approach.
Okay. Another thing that I want to add, that some people think that using the functional approach is hard. It's not hard, actually. It's just unusual. So it's not, I mean, you don't see like it's not wide that widely used object-oriented programming and object-oriented approach, and that might seem that that's the only reason I think that if, for example, let's say that if everyone would if the, let's say, functional programming functional approach would be the leading style of paradigm in all languages, I mean, vice versa would be people would consider that object-oriented is very hard to write, because I mean you're not just used to it. So that's the thing that I see. But as I said, I mean, if you are working in it, for me it took like the 4 months, I would say, to just to get used to it and to start to write. I mean just to feel comfortable. So in functional program. But as I said, I mean, the basics of it, you can even start to, if you're writing in Java, so even you can start to write in functional approach, even in Java. So I mean, when you will send your code to the review, some people will ask that what kind of style is that, because no one is like no one is used to it. But yeah. You can.
I only want to add that some points of approach that usually defined as functional approach, like immutability and pure functions, it works really great on refactoring, because when you reading just functions that get some params and return some values, and no magic with changes of some instances outside the function, it's so easy to understand and so easy to refactor that it just it's just hard to compare with situations when you need to read a code with a big amount of side effects.
I can agree that the only one point that I wanted to add is actually Arhan mentioned about the code style, right? And my experience was that in order to get like this high level of productivity with Scala as a team, you should really work together as a team for a long time. So you should work out your own code style. You should work out some specific best practices for your team, right? And that's why at least I consider that as a blocker for a wider adoption, because in big enterprise world, teams just don't live together for that long time to adopt those deep Scala practices and code style.
Honestly, I can't agree with it. Of course, there are some definitely bad practices that you just should discuss and to just restriction in your project, discuss how to implement some features in your project. But I can say that it's necessary to work for years in team to write good Scala code. No, there are just some common best ways to work, and it doesn't take long time to understand it. And some project-specific things that just should be described in some project documentation, and I don't see here any differences from Java project or project on any other language.
Okay, actually, sorry, I missed a part. So have you already discussed like typical development stack for Scala? Because I'm really interested in that SBT versus Maven story. Like why so is SBT really a go-to tool for all Scala developers? Why some teams use Maven instead of them? Because that was kind of a mystery for me.
Honestly, it's a mystery for me too, because from my experience, SBT is more preferable than Maven in some Scala projects. And in Scala, compiler do really a lot of work for you. Scala has very complex type system, and compiler could make a lot of checks, and it leads to quite slow compilation. So SBT by default support incremental compilation, and Maven, as far as I'm concerned, not. And this point is quite critical for Scala. But if you can set up incremental compilation with the Maven, here the only point is Maven is XML and SBT is some DSL on Scala, and just choose what's the best for you.
Okay. So Irina, just guide us. We're kind of out of our time frame. So should we or can we proceed, or should we probably stop here and proceed tomorrow during our next round?
I think we can proceed today. We don't have time, but we are live now. So if it is convenient for you, let's proceed.
Okay, yeah, and again, a question to audience. So just if you had anything in mind you wanted to discuss, or you wanted us to talk about, just don't hesitate, drop a message in the chat, or just raise your hand and say that you want to participate. Again, sir, I'm sorry if I missed all the interesting things, but is there like any area for Scala, for example, where it really rocks besides just BI? Not BI, but big data and just
Actually, yes, we
discussed that.
Yes.
Okay, you can just recap for me with one word, yes or no.
Then yes.
Okay.
Okay, for now, I think if we have a few more minutes, I could just, no one asked me about it, but I was sure that this topic will come, and it's implicit. So
Sure.
maybe you've heard about implicits in Scala. So that's a way to make some transformation of some objects, call some implicit parameters, just call them without calling, etc.
Basically,
Yes.
that for me, that one of the topics that really breaks that, as I've said in the very beginning, that unambiguity principle, right? So maybe I'm just using it the wrong way, but when implicits come into play, I'm completely lost in Scala code base.
Mm-hmm. Okay, that's a fair point, and that's the point when it comes, not strict technical measures, but strict technical ways to solve problem, but it's more code style. Because implicits could definitely help you to write just terrible code, yes. But actually, we don't need implicits to write terrible code. So we just need to have some agreement on projects. How can we use them? Where should we put our implicits, etc. So, for example, a really common case of work with implicits I saw, it's serialization in JSONs. So, for example, when we are working with Akka, we have some implicit marshallers, and it helps us to just, when we're reading a code, we read just business logic of code, less boilerplate, like he will take string and transform it to object, and he will transform our object to string before we sending it as a reply. So if we have some strict agreement that we have this way to work, we have implicit functions to create JSONs and create objects from JSONs, we will put them, for example, in some companion objects or in some predefined place. In this case, implicits, I think, will really help us to write code that will be more clean. In case we just take some random params or random values and make them implicits, and then we are trying to hide them anywhere in our code, that's a big problem. Yes, so implicits is one of topics that usually calls some questions. And I'd say that the way to work with this approach is just to define it on the level of project agreements.
Like the questions that came to my mind is, so when you say we just need to establish some agreements, right? Again, that easy comes to a point about which I was talking, right? When you need to have a mature team having the same mindset, right? And sharing the same set of practices and knowing all those unspoken truths, right? Or you need some automated way to control that. So have Scala developed any means to automatically control this?
At first, yes, we have some code style checkers, and we can create some quite complicated rules for these style checkers, and compilation will just fail if something is wrong. Yes, it could be implemented on project, but again, in all projects, in Java project without implicits, if we will just put some random functions in random places, and I have no idea why we store function for formatting data in JSON here and for this entity, and in just different other place for other entity, it won't look great anywhere. So yes, it's some agreements that could be enforced by tools and could be just achieved by some docs. But I'd say it's common situation for different programming languages. And I don't think that an opportunity to use implicits make a significant difference here.
Yeah, but that's like that just one of things that scare people? And
That's not just one of things. That's one quite big point in this, in terms of work with Scala.
But by the way,
So
do you have your own like top rating of controversial features of Scala, like things about which we can say, oh, okay, we're not sure that they are totally good?
Honestly, I say that in the most cases, problem is not with tools, it's with how we're trying to use these tools. So honestly, it's hard for me to just name some features that definitely shouldn't be used. For example, I can say it's not from Scala core, it's from Akka actors. That's a really interesting library. It implements an actor model that was invited a long time ago, long before Scala. And in case if we will start to put actors everywhere, it will create a code that very hard to read, very hard to support, and almost impossible to debug. But if we know some places where it's reasonable to use actors, and we use actors only there, and in other places we prefer some more suitable tools, that they will work well. So I'd say again, problem usually not with instruments.
Okay, yeah, I totally agree. Okay, I think that we can wrap up for today. Probably we will have another session tomorrow, and if we got any questions from audience after that, we can discuss them tomorrow, probably, right? I can only thank everyone for joining. Thanks our experts, Sergey, Maria, and Han for joining us in this discussion.
Thank you.
And yeah, probably
Thank you.
wrap up and get back to this with a Kotlin focus and probably some additions on Scala tomorrow, right?
Okay, sounds
Yep.
great.
Have a good
Okay.
afternoon, everyone. Thanks.
Thank you all.
Have a
Bye.
good rest of the day. Bye.